So in summary, momentum, which is mass times velocity, changes because velocity changes. But mechanical energy is the sum of potential energy and kinetic energy. And that together always stays the same. Although individually they may be changing, when one increases, the other decreases. So the total of potential and kinetic, which is mechanical energy, is always the same. In the second question, a 2 kilogram object is traveling east at 20 meters per second, collides with a 3 kilogram object traveling west at 10 meters per second. And after the collision, the 2 kilogram object has a velocity 5 meters per second to the west. How much kinetic energy was lost during the collision? Alright, this is a diagram that represents the motion. 2 kilogram at 20, 3 kilogram at 10 meters per second, and then after collision the 2 kilogram object is moving at 5 meters per second, and nothing is mentioned about the 3 kilogram object. So considering the conservation of momentum, the initial momentum before collision is 2 times 20 plus 3 times negative 10 because it's moving in the opposite direction. That gives 10 kilogram meter per second. And that is to the east because 10, east is taken as positive. And then I'm calling them object A and B. So that's after collision, the momentum of A is unknown, so I've just left it there, but the momentum of B is 2 times negative 5. Again, it's negative because it's moving to the west. And that should equal 10. Why? Because the total momentum before collision should be equal to the total momentum after. So if the total before is 10, the total after should also be 10. Now solving that gives PA as 20, which means velocity of object A is 20 by 3, which is dividing it by its mass. So we get 6.67 meters per second as the velocity of object B. Now we can just calculate the kinetic energy of each object. Kinetic energy is 1/2 times mass times velocity squared. So this is the kinetic energy before collision. Those are the masses and velocities before collision. You get 437.5 joules as the initial kinetic energy. And the final, I made some calculation mistake there. So it's actually 550 joules. And the final kinetic energy is likewise 91.73 joules. So the difference gives the loss. So 458 joules of kinetic energy is lost. In question number 3, a slender uniform rod. Slender means thin. So it's a thin uniform rod, 100 centimeter long, and it's used as a meter stick, and 2 parallel axes that are perpendicular to the rod are considered. The first axis passes through the 50 centimeter mark, and the second axis passes through the 30 centimeter mark. What is the ratio of the moment of inertia through the second axis to the moment of inertia through the first axis? Is the diagram. This is the axis that passes through the 50 centimeter, and then we have the axis that passes through the 30 centimeter. So we'll call them AB and CD. And according to the parallel axis theorem, ICD can be found out if we know IAB. And IAB for a thin rod is mass times length squared by 12, using which you get the length is 1 meter, so you get mass by 12. We do not know the mass of the rod, so it will remain as m by 12. And then using the parallaxes theorem, ICD is equal to IAB plus mass times square of the distance between the two axes. And in this case, the distance x is 20 centimeters. And we got IAB, which is m by 12, plus m times 0.2 in meters. And you get it as m by 12 plus 0.04 m. We really do not need to know the mass because we only need to find the ratio. So we'll take the ratio of ICD to IAB and do the math. The mass is going to cancel out. And when you calculate it, you're going to get the ratio as 1.4796, which is approximately 1.5. So that's the answer. In number 4, a 95 Newton force exerted at the end of a 0.5 meter long torque wrench gives rise to a torque of 15 Newton meter. What is the angle, assuming it to be less than 90 degrees, between the wrench handle and the direction of the applied force? So that requires a diagram, and that shows the wrench, 0.5 meter long, that's the wrench, and then we have the force being applied. The angle is theta, which is what we're looking for. Force is given as 95 newtons. And by the definition of torque, torque is Rf sine theta. Make sine theta the subject. Torque is 15 divided by 0.5 times 95. So we need to solve that and take the inverse sine of 0.316. We get the angle as 18.40 degrees. Now here is an easy one. A heavy boy and a lightweight girl are balanced on a massless seesaw. If they both move forward so that they are 1/2 their original distance from the pivot point, what will happen to the seesaw? Nothing will happen because both move the same distance, don't they? Both move actually 1/2 of what they were already at, so nothing is going to happen. D is the answer. Nothing will happen. The seesaw will still be balanced, because initially, if it was balanced when the distances were AB and CD, now if you make them half of what it was before, the equation still holds, so that means they are still equal. Number 6, a steel rod 55 centimeter long has a diameter of 30 centimeters. The compressive strength, that means the maximum stress it can support without breaking, is given. What is the compression force that would break the rod? Now the stress is given in this case, and you can calculate the area, so it should be easy to find the force. The compressive strength is given here. We can calculate the area using pi r squared because cross section is circular. And once you get that area, we can calculate the force, because force is nothing but F by A into area. And the answer is 3.53 times 10 to the 7 newtons. In the seventh one, a child is trying to stack two uniform wooden blocks, both 12 centimeters in length, so they will protrude as much as possible over the edge of a table without tipping over. What is the maximum possible overhang distance D? This is really simple one, because you got to know that the brick on top, if it should not topple over or tip over, then its center of mass should be positioned in such a way that the vertical line drawn through it should lie inside the base. So here I'm making some markings, and hopefully we can explain that. Now here you have 6 and 6. The center of mass of the top brick should be right at this point, which is its center, and then the combined center of mass of both of the bricks should be here, so that the vertical line through that is just inside the edge of the table. So if you look at the symmetry of the diagram, you understand that this has got to be 3 centimeters, and this is 6. Therefore, 3 plus 6 is 9 centimeters is the answer. You can see that I've redrawn this diagram to make it the actual way it is, and you can see that this edge coincides with the center of the other one. So that's why we get this to be exactly half of 6, which is 3. I hope that makes sense. Now in this question, the diameter of the wire is given and how much it stretches is given. 0.5% means the change in length divided by the original length is 0.5 by 100. So that's clear there. So it's a straightforward question. First, find the area of cross section using pi r squared, and here I've actually used 0.3. I've used 0.3, but I wrote down 0.6. So you get that as 0.28 times 10 to the negative 6, and then plug it back into this. You get 1.4 times 10 to the 10 Newton per meter squared. Now, of course, tensile stress is the applied force per cross-sectional area. Stress is force by area. Tensile means acting lengthwise. So that's a simple thing. Which one of the following stresses would be most likely to cause a bone to fracture? Of course, it's going to be the shear stress, because a compressive stress is when the bone carries the weight of the person and the force is acting lengthwise, which it can take. Same with tensile stress or bulk stress, but shear stress is involved when you're trying to twist something, so the human bone cannot take a twisting force. That is why if you step somewhere at a wrong angle, that tends to twist the bone and it can't take the shear stress. Now on this one, if the torque on an object adds up to 0, the object could be both turning and accelerating linearly. Now take a minute to understand this. If the torque is 0, you know that torque is I alpha, means that alpha is 0, which means it's not accelerating. That's correct, but it's still turning. You know, it's turning with a constant angular velocity. And it could be accelerating, because if you look at a sphere rolling on a horizontal floor, you can see that the center could be accelerating. The center is accelerating, see? So which means the angular velocity is still constant, the center is accelerating. And so you could see that the object could be both turning and accelerating linearly. And in this question number 12, a light triangular plate OAB is in a horizontal plane and three forces, 6 Newton, 9 Newton and 7 Newton act on the plate, which is pivoted about a vertical axis through point O. So the pivot is at this point. We have the forces here, 6, 9 and 7. Consider the clockwise sense as positive, and we have to find the sum of the torques about the vertical axis through point A. Now remember that this force is acting right at the pivot and does not produce any torque. Now this one produces a clockwise torque because it's trying to turn it in the clockwise direction. And to calculate the torque, we would need to find the horizontal component and multiply it with this distance. Because whenever you calculate the torque, you have to take the product of the force with the perpendicular distance. So either you can resolve the force into the horizontal and multiply it with this, or another way of doing it would be to take this distance, you see the one that I'm drawing, and then multiply it with the actual force itself. But that's going to be tough in the situation, or tougher, so I'm going to go with the first option. Now when it comes to F2, the force itself is perpendicular to this distance, so you just have to multiply the force with this distance to get the counterclockwise torque. And remember that the clockwise is to be taken as positive. So that's 6 cosine 30. And so 6 cosine 30 times 0.6 is going to give the clockwise. While 9 multiplied by 0.80 is going to give the counterclockwise, which has to be taken as negative. Therefore, the net force would be 7.2 minus 5.70. So the clockwise is actually 3.11 Newton meter, and the counterclockwise is 7.2. So when you take the difference, you get 4.08 Newton meter. Now in this question, there are three solid uniform cylindrical flywheels, each having the same mass and radius, and they rotate independently around a common axis. Two of the flywheels rotate in one direction at 3.83 radians per second. The other rotates in the opposite direction at 3.42 radian per second, and we have to find the magnitude of the net angular momentum of the system. So first we can find the rotational inertia, and angular momentum is I omega. Rotational inertia of a flywheel, which is a disk, is mr squared by 2. So you get rotational inertia, and then two of them have that angular momentum, so I multiplied it with 2 times I times omega, and then the third one is rotating in the opposite direction, so that's going to be negative I times omega. So when you do that calculation, you get 297.76, and those are the units of angular momentum. This here is an interesting question because it says while spinning down from 500 RPM to rest, a solid uniform flywheel does 5.1 kilojoules of work. If the radius of the disk is 1.2 meter, what is its mass? It looks like the work is given, but actually remember that work is equal to change in kinetic energy. Remember the work energy theorem. So although 5.1 kilojoules is mentioned to be the work, it's actually the kinetic energy, because the final kinetic energy is 0. And then it becomes easy because we know that kinetic energy is given by kinetic energy is 1/2 I omega squared, and I is mr squared by 2, because once again the flywheel is a disk, and that's why it's mr squared by 2. So when you do that, you get the kinetic energy, which is equal to 5,100 joules, and from there you can find the mass. Of course, initially we had to find omega by changing the RPM into RPS, which is the rotations per second, which becomes the frequency, and then multiplied with 2 pi. So you get that omega, which is what I've used here, and then set kinetic energy is equal to that formula, plug it in, you get the mass. So the important thing here to remember was, although it's mentioned to be the work, it's actually the change in kinetic energy, or the kinetic energy. Now in this question, a 310 gram air track cart is traveling at 1.25 meter per second, and then a 260 gram cart travels in the opposite direction at 1.33 meter per second. You have to find the speed of the center of mass of the two carts. Now, just like we find the speed, just like we find the position of the center of mass, we have this formula where velocity of the center of mass is mass times velocity of the individual particles divided by the total mass. So now you got to change this into kilograms. That's why it's 0.310 times 1.25. And since the other is moving in the opposite direction, there's a negative. So take the product of the mass of each one with the velocity of each one, add them up, divide by the total mass, and you will get the velocity of the center of mass. That is 0.0732 meter per second, as in this case. Here is an interesting one. This is a special question because this question clearly mentions that it is an elastic collision. So you have a car colliding head-on with a truck, and spring-mounted bumpers ensure that the collision is essentially elastic. If the velocity of the truck is 17 km per hour in the same direction, after the collision, what was the initial speed of the car? So it is an elastic collision, and if it is an elastic collision, we know that V1 minus V2, which is the difference in their velocities before collision, should be equal to V2 prime minus V1 prime. Now, V1, the prime shows their final velocities. But just note that it's backwards here, okay? So the difference in their velocities before collision should be equal to the reverse difference in velocities after collision. And this formula, once again, will only work for a perfectly elastic collision. So knowing that, we can substitute. We know that the truck was parked, so its initial velocity is 0. And then you have 17 minus V1 prime. So that's a special formula. And then when you apply the principle of conservation of momentum, mass times velocity is momentum, and when you add the total momentum before should be equal to total momentum after. But here we need to change the velocity into meter per second, which I've now done. I changed the kilometer into meter per second. So that is the total initial momentum before collision is equal to the total after collision. And then you get that equation, substitute for V1 prime from here, because when you take it to the other side, you get V1 prime as 4.72 minus V1 from this equation, right? And then substitute that and calculate. It is just a matter of bringing out V1 to one side and calculating. Get the answers 5.155 meter per second, but since the answers are given in kilometer per hour, I just brought it back into kilometer per hour. Here in question 18, a car heading north collides at an intersection with a truck of the same mass as the car heading east. If they lock together and travel at 28 meters per second at 46 degrees north of east just after the collision, how fast was the car initially traveling? Alright, so here's the diagram, one moving north, the other moving to the east, and then they lock up and move together. So we have the final velocity and we have the total mass, so we can find the total momentum after collision. So the idea is get that momentum, resolve it into the x and the y components, and the x component should be equal to the momentum of the truck, and the y component should be equal to the momentum of the car. So here it is. This angle is 46 degrees, and know that this is 2m28 cosine 46. Because both have the same mass, the total mass is 2 times m times velocity cosine 46. And so the vertical would be 2 times the mass, 28 sine 46. And the vertical component should be equal to the momentum of the car. So I set them equal to each other because the total momentum before along the y-axis should be equal to the total momentum after along the y-axis. The masses get cancelled out and you get the velocity as 40.28 meter per second. And in this question, there are considered 2 less than desirable options, both not desirable. In the first, you're driving 30 miles per hour and crash head-on into an identical car also going 30 miles per hour. In the second option, you're driving at that same speed and crash head-on into a stationary brick wall. In neither case does your car bounce off, and the collision time is the same. Which of these 2 situations would result in the greatest impact force? The forces would be the same in both cases, because force depends on the rate of change of momentum. So force is equal to dp by dt. Change in momentum of the car is the same because it says it doesn't bounce, right? So it has a certain momentum and then final is 0. So as long as the change in momentum and the time are the same, the force on the car should be the same. Although you would think in your head in a wrong way and think that, well, collision with the other one should be creating a greater force, it's not true. And in this last one, a shell explodes into 2 fragments, and one fragment is 25 times heavier than the other. If any gas from the explosion has negligible mass, then which one of these statements is true? Now, the easy way to understand it is imagine that the shell is at rest. So its initial momentum is 0, correct? And therefore, when it breaks into 2 fragments, if one fragment goes in the positive direction, the other fragment has to go in the negative direction, and their momentas must be equal. Why? Because when you have 2 quantities that are equal and opposite, they equal 0. I hope you understand what I'm saying. Since the total initial momentum is 0, the total final momentum has got to be 0, which means both of them should have the same momentum. That's why it says the momentum change of the lighter fragment is exactly the same as the momentum change of the heavier fragment. Remember that these questions are just a pointer to how you should prepare for the exam and how deep your learning is supposed to be. So it's not just cramming certain formulas, but it is understanding the concepts. So thank you all and good luck.